You've probably heard this idea before, right? That our reality, deep down, is like a giant simulation, that the universe is made of these tiny, fundamental pixels. It's an incredibly cool concept, but what if that whole picture is just plain wrong?
Yeah, this is the big one, isn't it? Is there a fundamental resolution to reality? A point where if you could just zoom in far enough, you'd hit the bottom, the ultimate indivisible building blocks of space itself.
So this concept, which you might hear called digital physics, basically says that yes, there is a minimal resolution, and the usual suspect for that smallest possible pixel? Something called the Planck length, an almost impossibly tiny scale. And on the surface, it feels so tidy. But as we're about to see, this popular idea might just be a profound misunderstanding of how the universe actually works. All right, so first up, let's start poking some holes in this nice, simple picture of a grid-like, pixelated reality. In this quote, this just cuts right to the heart of the problem. It's asking us to completely shift how we're looking at this. It's not about what the universe is, it's about what we can know about it. And trust me, that one little shift changes everything. Okay, let's dive right into the core of it. We're going to put the main suspect here, the Planck length itself, under the microscope. Okay, so this is where the big mix-up happens. On one hand, you have the myth, right? The idea that the Planck length is this tiny, physical Lego brick of reality, the absolute smallest thing. But the reality is, well, it's way weirder and more interesting than that. It's not a physical thing. It's a limit on what we can see. Think about it. To see something that incredibly tiny, you'd have to hit it with a ton of energy. So much energy, in fact, that you'd instantly create a tiny black hole and poof, the very thing you were trying to measure gets swallowed up. It's literally the point where our ability to tell one location from another just breaks down. And that's exactly what this quote is getting at. The Planck scale isn't the edge of the universe. It's the edge of our ability to distinguish things. It's a limit on our knowledge, not on reality itself. So, just to be super clear here, the Planck length is not some magical point where space-time just shatters into a million tiny pieces. The source material is really blunt about this. Calling it a fragmented or broken up point is, and I'm quoting here, nonsense. So if it's not pixelated, then what is it? Well, the most likely answer is that it's just smooth, continuous. Physicists talk about it being flat enough, even at that insane scale. The universe doesn't just stop existing where our instruments can't see anymore. Its smoothness just keeps on going, way beyond the horizon of our perception. All right, let's tackle the next piece of this puzzle. Because if it's not pixels, a lot of people jump to another big idea in digital physics, often summed up with the phrase, it from bit. Which brings us to this question, okay, fine, not physical pixels. But what if the universe is fundamentally made of information? Like we're all living inside some giant cosmic computer program? Well, it turns out the argument against this is pretty straightforward when you break it down. Information can't be the fundamental building block for a few big reasons. One, information needs an observer, right? Someone or something to define it and make sense of it. Two, our entire concept of information is built on our own tools, man-made numbers. And three, and this is the big one, the thing has to exist before you can have information about the thing. The physical reality has to come first. So what is information then? It's not the universe itself. It's our description of it. It's something that comes after the fact, a tool we invent to map out reality, not the reality itself. Okay, so now we can put it all together. We have this misunderstanding about the Planck length, and we have this misunderstanding about what information is. And when you combine them, you see the fundamental mistake that leads to this whole pixel paradox. This table lays it out perfectly. On the left, you have ontological reality. That's a fancy way of saying the way things actually are. And on the right, you have our human constructs, like information. And just look at that resolution row. Reality itself, probably continuous. Our information about it, limited and broken up into pieces. We've been looking at the pixels on our map and thinking the world itself is made of squares. We're mistaking the map for the territory. And there's actually a name for this kind of logical mistake. It's called a category error. And it's a really useful idea to have in your back pocket. It's what happens when you mistake the measurement of a thing for the thing itself. Oh, and I absolutely love this quote because it gives you such a perfect mental image of what's going on. Saying the Planck length is a physical pixel, it's like thinking the little millimeter marks on your ruler are actual physical grooves carved into the fabric of space-time. It's just us projecting our own tools onto the universe. So now that we've kind of dismantled this whole pixel myth, let's pull back and appreciate the new and honestly way more profound picture of the cosmos that this leaves us with. And it really comes down to this single powerful statement. When you're talking about what the universe is actually made of, the search for a smallest piece, a minimal resolution, it's just the wrong question to ask, because the universe just isn't built like that. So the big takeaways here are these. First, reality at its core is almost certainly continuous and smooth. Second, the Planck scale isn't a wall at the end of space-time. It's a wall at the end of our knowledge. And third, information isn't the ingredient. It's the recipe we write down after we've tasted the food. And that leaves us with a much more exciting and honestly much more mysterious question to ponder. We now know the universe doesn't stop just because our equations and measurements do. So the real mystery isn't how small do the pixels get. The real mystery is what incredible continuous reality lies waiting for us just beyond that horizon.